In today's video, we are going to do this practice question from the topic coordination compounds. In the previous video, we have done 6 practice questions from the topic coordination compounds, which cover the NEET PYQs plus some extra questions. If you haven't watched that video, just go to the playlist, you will find that. Okay, let us do this one. The complex which is strongly paramagnetic is which one? Here you have to find out the number of unpaired electrons. The complex which has many unpaired electrons, that will be strongly paramagnetic. Clear? Let us do. Number 1, we calculate the number of unpaired electrons in the central metal atom. First, find the oxidation state of the central metal atom iron. Let that be X plus 6 into the charge carried by the ligand equal to minus 3. So from here, X is equal to plus 3, right? Which means that iron is in the plus 3 oxidation state in this complex. Next, write the electronic configuration of iron. Argon 3d6 4s2. Now in the plus 3 oxidation state, we mean that 3 electrons are lost. So 2 electrons are lost from the 4s and 1 from the 3d. Then we are left with 3d5, 4s0. Clear? Now this one is a strong field ligand. Since it is a strong field ligand, these 5 electrons will pair up. So they start pairing. And we have 1 unpaired electron. So the number of unpaired electron in the central metal atom in this complex is 1. So here N is equal to 1. Second one, what is that? Fe H2O 6 3 plus. Find the oxidation state of the central metal atom. X plus 6 into the charge of this one, it is 0 plus 3. So iron is in the plus 3 oxidation state in this complex. Write the electronic configuration. We have argon 3d 6 4s2. In the plus 3 oxidation state, we have argon. 2 electrons are lost from the 4s, 1 from the 3d. Then we are left with 3d5, 4s0. One, two, three, four, 5. Now this ligand is a weak field ligand, so the electrons will not pair up. Then how many unpaired electrons we have here? 5. Here N is equal to 5. Next, find the oxidation state of nickel. 4 into minus 1 equal to minus 2. So nickel is in the plus 2 oxidation state in this complex. Write the electronic configuration. Argon 3d 8 4s2. In the plus 2 oxidation state, we have argon. 2 electrons are lost from the 4s, so we are left with 8 electrons in the 3d. This is a strong field ligand. So 1, 2, 3, 4, 5, 6, 7, 8. Since it is a strong field ligand, these electrons start pairing up. Here we have no unpaired electron, so N is equal to 0. Okay, and then the fourth one, Mn Cn6 4 minus. Find the oxidation state of manganese. 6 into the charge carried by the ligand equal to -4. So here manganese is in the +2 oxidation state. Next, write the electronic configuration. Argon 3d5 4s2. In the +2 oxidation state we have argon, 2 electrons are lost from the 4s, we are left with 3d5. This is a strong field ligand. 1 2 3 4 5. So being a strong field ligand, these electrons start pairing up. And we have only one unpaired electron. So here N is equal to 1. Among these, the complex which has the maximum number of unpaired electrons is this one. So this is strongly paramagnetic.